This is differential equations, section 2.2. We're now going to do activity 222. And in this one, we've got a differential equation. Here, beta is 1/2. So we have dx dt equals x times 1 minus x minus 1/2 xy, and dy dt equals y times 1 minus y minus 1/2 xy. So here, system. And now we want to find the null lines for the system and the equilibrium points for the system. So a great way to do that is we want to know when these things are 0. So factoring them as much as possible will often help. So dx dt equals x times 1 minus x minus 1/2 y, and dy dt equals y times 1 minus y minus 1/2 x. And so we can set both of these equal to 0 to find null lines for x, and both of these equal to 0 to find null lines for y. And anywhere where they're both 0 would be an equilibrium point for the system. Let's on Desmos, let's graph those lines. So let's see. So I'm going to set x equals 0 and y equals 0 and 1 minus x minus 1/2 y equals 0 and 1 minus y minus 1/2 x equals 0. And then let's use a color scheme to help us. So let's use red for the x null lines. Let's use blue for the y null lines. Okay, so let's zoom in on this. And so anywhere where a red line touches the blue line is an equilibrium point. There's equilibrium points there, there, and there, and there. Those are our 4 equilibrium points of the system. Okay. So now plot the direction field. Well, let's do that in Sage because, or I could add this to the, here, let's pause this and so here I am in the Desmos plot. Because we're zoomed in a lot, the plot's not helping me as much, but I do have this point I can drag around, which is pretty fun. And so I have the null lines here so that when I'm on a red null line, I'm vertical. And when I'm on a blue null line, I'm horizontal. Okay? And then anywhere where they both touch is an equilibrium spot. So here, notice that 0, 0, anytime I'm either going towards it or away from it. I don't have a drawn arrow here, so you can't really tell. But I would bet that it's going away from it based on the nature of the problem. And then here, this is also, everything's pointing there. Bet that we're going towards that point. And here, these points, notice how it kind of curves like that. So these would be sources that kind of goes away from those points, avoids those points. So maybe we can do this on Sage too. Let's do that. And here we plot it with Sage, where the green are the y null lines and the red are the x null lines. And we see that with this diagonal null line, everything's going that way. And with this red one, everything's going that way. And with the green one, going down and going down. And so if we start here, it goes like that. So here we're starting with our initial conditions is t is 0, x is 0.1, y is 0.5. So starting there, and it just goes to that equilibrium spot, which would, I guess, be 2/3 and 2/3 of the carrying capacity for each competing species. Kind of fun, right? So that's using SAGE.